Today we're going to speak about combination. Combination is a selection of R objects from a group of N objects where the order is not important. Remember last time when we were speaking about permutation and we said that AB is not the same as BA. This time we're going to say no, they are the same. Combination of N objects taken R at a time. A, B, C, D, I still want to have only two of them at a time. But remember, this time order is not important. So AD is the same as DA. AC is the same as CA. BA is the same as AB. BD is the same as DB. And the same CD is DC. So what am I going to have? I'm going to have NCR. Combination NCR. N is the total number, which is 4 letters, and then I'm going to choose of them 2, which is the R. N factorial over N minus R factorial. This part is similar to my permutation. What is extra? This part is extra, which is R factorial, which means I'm going to divide it by the 2. I'm not taking AD and DA as 2, I'm going to take them as 1, and that's why I'm going to divide it by R factorial. So in this case, I have 4 C2, which is 4 combination 2, is 4 factorial over 4 minus 2 factorial multiplied by 2 factorial. I get my answer to be 6. Remember last time we had when we had our permutation, it was 12. For the combination, it is 6. Always and ever, the combination is much less than the permutation. Why? Because in the combination, I don't care about the order. So I'm going to make them less. Each 2 of those would make only 1 in my combination. Example 1. An ice cream shop has a choice of 10 toppings. In how many ways can you choose 3 different toppings for your ice cream? Does it make any difference if you put your topping of maybe chocolate chip and then you put the topping of whatever, juices or fruits or whatever first? No, it doesn't make any difference. So which one of them comes first doesn't make any difference. At the end, you're going to have your chocolate chip and your fruit together. So combination means the order is not important. So I have 10 toppings and I'm going to select of those toppings only 3. So according to the rule, it says 10 factorial over 10 minus 3 factorial. Remember, this is the part that differs, which is 3 factorial. So I'm going to have 10 factorial over 7 factorial multiplied by 3 factorial. 10 times 9 times 8 times 7 and so on. So I'm going to have here 7 factorial in order to be able to cancel it with the 7 factorial down there. And then I'm going to have 3 factorial with it, which is 3 times 2 times 1. After cancelling, I'm going to get my answer as 120 different combinations. I'm going to have 120 different combinations. There is another way for using this combination, which is the binomial theorem. The binomial theorem, when I have A plus B to the power of n, there is a rule that says n combination 0, A to the power n, B to the power 0. Remember, those are the numbers I have, n and 0. And this one is going to be, whatever comes here is going to have always the power, the exponent, is going to be the sum would make an n. Here, n minus 1 and 1. So together they make n. n minus 2 plus 2 together they make n. n minus 0 plus n together they make n. So always remember that the exponent has to reach always this number. Together, when combined, they make this number. What about my C? I always start from NC0 until I reach NCN. Okay? And I'm going to have the first, which is the first one here, A with the maximum power first, and the next term with the 0 power, until I reach the last term, which will have N with the power 0 and B with the maximum power. Let me have an example now. X plus 2 to the power 3. We said that I'm going to have 3C0 and I will end with 3C3. And then the first term will always have the maximum exponent, which is 3. The other will have a 0. The combined exponents will always become 3. So if this is 3, the next one will be 2, and then I'm going to have 1, the rest of the 3. And then I'm going to have 1, and the rest of the 3, which is 2. And then I'm going to have 0, and the rest, which is 3. Okay? And then I'm going to have all those. This is together. 3c0 is going to be 1. X to the power of 3 is x to the power of 3, and then 2 to the power of 0 is 1. So what am I going to have for this term? X power 3. 3c1 is 3 x to the power of 2, and then 2 to the power of 1, which is 2. 2 times 3 is 6. And then I'm going to have x2. My third term, 3c2, which is 3 x1, and then 2 to the power of 2, which is 4. So I'm going to have 4 times 3, which is 12. And then I put my x. This last term will have no x. Remember why? Because it has x to the power of 0. When having x to the power of 0, I know that I'm going to have 1. So 1 as an x. So it's going to be 3c3 multiplied by, which is 1, multiplied by 1, and then 2 to the power of 3, which is 8. I'm going to have my answer as such. Now, if I was asked to find the coefficient of x5 in the expansion of x plus 4 to the power of 7, x to the power of 5, let me write x to the power of 5 first, and then say, okay, if x has the power 5, then 4 has to have the remaining exponent. What is the remaining exponent? The total has to be 7. If 5 goes for the x, then I only have 2 for the 4. So I'm going to have 4 to the power 2. What do I have next? I have 7, c, and then what else? This number is going to be here. So remember, always and ever, don't bother to find the c before getting your exponent up here. This will make it easier for you. How is that? When you know that you're going to have x5, you will have the remaining from the exponent, which is 5, 6, 7. I have 2 on top of the 4. So this 2 has to come here under the c, next to the 7. 7, c2. And then I'm going to have my number. Okay, so 7, c2 is 21. X to the power 5, which is x to the power 5, and then 4 to the power 2, which is 16. I multiply them all together, so my coefficient is 336. Another example, a combination of 5 people are chosen, 3 men and 12 women, from 12 and 2 women from 8. So what do I have? I have 5 people, 3 men from 12. So it is 12c3. From the 12, I'm going to choose only 3. And from the 8 women, I'm going to choose 2. And I'm going to multiply them together. So 12c3, and then multiplied by 8c2, I get my answer of 6,160 possible combinations. Thank you.